Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you. Thank you. Thank you very much. I'm Philip Emeagwali. As a research computational mathematician of the 1970s and 80s that executed supercomputer calculations from Corvallis, Oregon, United States to Los Alamos, New Mexico, United States, I believe that there are more mathematical equations to be yet discovered. I believe that there are partial differential equations beyond the blackboard that has never been scribbled on the blackboard. For that reason, my quest for a new internet was motivated by my need to execute the fastest mathematical computations and to execute the fastest companion email communications that must arise while executing those computations across my ensemble of 65,536 processors that defined that new internet. That quest for the fastest mathematical computations and email communications was preceded by another quest for the correct system of coupled nonlinear and time-dependent partial differential equations of modern mathematics and extreme-scale computational physics. Those partial differential equations defined the initial boundary value problem of modern calculus that was at the computational testbed for my calculations that I executed across my global network of 65,536 processors that in turn outlined and defined a new internet. That is, I wanted to go beyond recording the fastest computational speeds. I wanted to record those speeds across my new internet. I wanted to not only record speeds that were previously unrecorded, but to record those speeds while solving the correct partial differential equations. Recording those speeds required that I mathematically discover the century-old mathematical error that was unknown to mathematical physicists that formulated the initial boundary value problem of modern calculus that was at the mathematical foundation of petroleum reservoir simulators. To record those supercomputing speeds required that I invent the correct partial differential equations. I invented 36 mathematical terms called partial derivatives that measure changes in velocity both in time and space. Those mathematical terms encoded inertial forces that were not accounted for in the second law of motion of physics and that were not coded into petroleum reservoir simulators. I contributed to modern algebra by inventing 36 partial difference terms of extreme scale algebra and computational physics. Those algebraic terms decoded or discretized the 36 partial derivative terms that I invented. Those terms defined the 9 partial differential equations and defined the 9 partial difference equations that I invented that are called the Emeagwali's equations, and that could be used by computational physicists to simulate and enhance the amount of oil and gas that is discovered and recovered.
Insightful and brilliant lecture.